the network didn't permit us, and my head was even aching. So we are talking about application of differentiation. We studied differentiation. Now we are going to apply application of differentiation. And so application of differentiation, applying differentiation. Now, when we talk of the dy dx, then we are using the slope. I didn't start from beginning, but I know when we talk of dy dx in the previous classrooms or in our previous math class, we are talking about the dy dx is simply the slope of a line, of a straight line in a graph, dy dx. And so the dy means change in y, all over. Dx means change in x. That simply means, and so change in y and all over change in x. And you know, we only use change in y all over change in x when we are finding the gradient of a straight line. That means in a graph. Now, under the application of differentiation, we are going to use that of the gradient of a curve. The gradient of a curve. And so, you know, those of us who have done quadratics, you know, when we are talking about a curve, we are talking about a certain y is equal to s squared, a certain y is equal to s squared plus 2, this and all those things. That gives us normally a curve, a diagram in a curve on a graph. And so when we have something like that, then if you have to find for the slope, you know that if you find the slope of a curve, you have to draw a line tangent. You have to draw a line tangent to the curve. And after drawing the line tangent to the curve, you are going to find the points, the 2 points, then now, or the coordinates. Then you come and find, what do we call it? You come and find the slope or the gradient. Now, after finding the gradient, then you are asked to find for the equation of the tangent. So you now come and find the equation of the tangent. And you know, right from, if I want to remember the topic we did this, I think still quadratics or polynomials or somewhere. Finding the equation of the tangent, the formula is straight. When you're given coordinates, maybe AB. So when giving coordinates AB and finding the what do you call it, the equation of a tangent, your formula always remain y minus y1 is equal to the gradient times into brackets s minus s1. Here we can say that 1 minus y minus b, where b stands for y1, is equal to the gradient. Now here the gradient will be, because they are doing differentiation, the gradient will be the differential of the equation you'll be given, the equation you'll be given in the question, times, what do you call it, s minus 3 times s minus 3. Sorry, s minus x1 or x minus a. That is what it's going to be. Now, when we are talking about, because the gradient of the tangent to the curve, the tangent and the normal are perpendicular. Normally, when you are finding for the normal, you reciprocate the, what do you call it, the gradient. So if the normal was m, when you are finding for, what do you call it, if the gradient for the tangent equation was m, when you are doing that for the normal, because the tangent and the normal, they are perpendicular, you have to reciprocate it. So in other words, you are going to get 1 all over m, but it's still going to be used the same equation. We are going to delve much deeper and you understand. And so if I'm giving coordinates of, maybe if I'm giving coordinates of if I'm giving AB coordinates, let me say A and B coordinates, and I'm given an equation, let's say y is equal to x raised to the power 2, x raised to the power 2, then what it means that I'll first have to find for the differential of x raised to the power 2. So find the differential of x raised to the power 2, I'm going to get, when I write f prime means dy dx, that's what it means, f prime. That's the first derivative. F prime. Oh. When I write f prime like this into bracket x, then it means that finding the derivative of if it's f of x, you know f of x is the function of y with respect to x. In other words, differentiating y with respect to x, that's what it means. So immediately I write f prime x, then it means that I'm differentiating, when the class ends, we start again. It means that I'm differentiating f of x. You know why? is the same as f of x. So when I write f prime x, then it means that I'm differentiating y with respect to x. And because it's just one prime, it means that I'm differentiating it only one time. Or that means it's the first order differential. Now, if it becomes f prime prime, then it means the second order derivative, like I taught you the other time, or d square y all over dx squared. That's what it means. And so if I'm to differentiate this, I'm going to get 2x. That we already know. I'm going to get 2x. Now, the equation is given that the equation of the tangent is given that y minus b is equal to f prime, what is it, f prime of a times x minus a. That's what it means. So this is the equation we are going to use to find for the equation of a tangent. We are going to solve questions, so we are going to understand. That simply also means that is after finding for the differential, we substitute this one in it, the a in it, and we come and get our gradient, which is we are going to get our answer. Then we come and substitute it here. We are going to do questions, so we are going to do this now. So this becomes the equation of a tangent. Equation of a tangent. And you know a tangent is the line that touches, what do you call it, the curve. And that helps us to find the equation of a curve and the gradient of a curve and so on and so forth. Now, since the normal and the tangent are perpendicular, then it follows that the gradient will be reciprocated. That is to say that if you still have the point, your point may be P at point P, you have your coordinates to be A and B. A and B are your coordinates. You have a coordinate to be A and B. Now, if you are finding for your equation, then that means instead of f here was to be your distance, f of a, then that means this is your f of a, where we are talking about, let's say, our gradient. We are going to reciprocate it. So this one will be 1 all over f of a, and we are going to negate it as well. We are going to negate it. So therefore, the gradient of the normal to the curve y is equal to f of x at the point AB is given by minus 1 all over f of a. So now the equation of the normal at point AB, we are going to get our same equation, just that there will be a slight change. Sorry, is equal to minus 1 all over f of a, f prime of a, f prime of a times into bracket s minus a, times into bracket s minus a. So these are the two equations we are going to use. These are the two equations, and this one is find the equation of the normal. Equation of a normal. This we've already done it, so it's not. I know you've already been taught this equation. Find the equations of a curve and so on. So that is what, this is the formulas we are going to use. So we are going to solve a typical example that will help us understand the equation better. And so let's pick this question. Now, find the equation of a tangent. Find the equation of the tangent to the curve. Find the equation of the tangent to the curve. 2x cubed to the curve 2x cubed minus 5x squared minus 5x squared minus 5x squared plus 3x minus 6 at the point, so the point is 1 minus 6. So these are our coordinates. 1 minus 6. And so we have to find for the equation of the tangent given these parameters. So number one, this is your equation. And so in other words, f of x is equal to this. And you at the point. So looking at the equation, this becomes our a and this becomes our b. I hope you are getting it. And so let's do our solution. So solution, f of x is given by 2x raised to the power 3 minus 5x raised to the power 2, 5x raised to the power 2 minus 3, plus 3x minus 6. So that's what we've been given. Now looking at the equation, that's the equation we are going to use. So we first have to find for the differential of the equation. That means f prime. And so find for f prime, f prime. Our f prime will give us, help me in. So 2x cubed will give us what? We are differentiating respect to this thing. What are you getting? 6x squared, right?
Wait.
6x squared. Let's go. 6x squared minus
10x.
minus
10x.
10x.
Plus 3.
Plus 3.
3.
Plus 3. Sorry. Plus 3. So there's our f of x. Then they said now we should find for f of a. This f of a means that after find, now we are finding for the gradient. So after taking the first differential, which is dy dx, then we can come and substitute the x into it. And so we have the a values. So f prime of a. Please, if you mute your listener. So f prime of a, what is to the network? So by n right now. So we are finding. Hello.
Hi.
So we are finding f prime of a. F prime of a.
Yes, sir.
So f prime of a will simply mean that we will substitute the a into the derived or the differentiated f of x, which is f prime. And so we had 6x squared minus 10x plus 3. So anywhere we see the x, we substitute in our a, and here our a using the coordinates as 1, right? So we are going to get 6 into brackets 1 raised to the power 2, which is the same with this thing. So I wouldn't even have to bother. Then 10 into bracket 1 plus 3. What are you getting? F prime
Minus
of a.
1.
Negative 1.
So our f prime of a is given by negative 1. Negative 1.
Yes.
Please, when immediately this thing, you mute your destiny so that we don't get the feedback from the back. And so now we have this. Then now we come and substitute it into our general equation. Our general equation is what? Y minus b is equal to, someone show me, is equal to what?
F prime.
F prime.
F prime.
F
Into f prime of a.
F prime of a into bracket
Times
x